In recent times, pulverized coal has emerged as the most widely used fuel in the steel re-rolling mill sector. However, in order to get the optimum output, it is important that the supply chain of coal is properly maintained. The coal typically used in the SRRM sector is characterized by high ash and low calorific content. This leads to premature cracks and failure of the refractory lining. Ash deposits require more heat to be added to the charge for attaining the desired temperature, thus increasing burning losses. Also, high ash content leads to choking of the recuperator tubes. This necessitates frequent cleaning, thus high maintenance cost and reduced performance of heat exchangers. The ideal size of pulverized coal should be at least 75 to 80% of 75 microns. In the conventional systems, fine coal ranges from only 10 to 30% of 75 microns. Non-uniform coal particles undergo partial combustion and result in deposition on the furnace walls. These coarse particles escape from the furnace with flue gas in the form of unburnt carbon or ash. The energy-efficient alternative to using pulverized coal as fuel starts with the procurement of good quality coal. Coal with high calorific value and low ash content, for example, Assam coal, is the most ideally suited for use as pulverized coal. The next step is to process or pulverize the coal into the desired fineness consistently. To do so, certain modifications in the pulverizer are required. The critical components of a pulverizer are a hammer, a mild steel liner, a classifier, and an inbuilt blower. For better and long-lasting quality of pulverizer, the metallurgy of the hammer should be improved to increase its resistance to wear and tear. The suggested additions to be made while casting of the hammer consists of manganese 13%, carbon 1.13%, silicon 0.4%, sulfur 0.003% and phosphorus less than 0.2%. Proper dimensions and thickness are to be ensured in the classifier. Grooved EN31 hardened steel plates or casted high manganese should be used in the liners. This will help achieve 65 to 80% of the desired 75 microns. The performance of a coal pulverizer can be gauged from the size and uniformity of the coal output. Let's take an example of a 10 TPH rolling mill to understand the economics. Typically, a furnace will have an annual fuel consumption of 3 crores 24 lakh rupees. With the use of energy-efficient system, the savings in specific fuel consumption shall be about 15%, which implies savings of rupees 16.2 lakhs annually. The modified pulverizer will entail an investment of 7 lakh rupees. Thus, the investment can be recovered in less than 5 months. For ensuring optimum performance, a pulverizer should be regularly maintained. The pulverizer components should be replaced periodically. It is proposed that a bomb calorimeter be used for in-house quality checks of coal. A metal sieve of -200 mesh size or 75 microns can be used for measuring the coal output.